Today we're going to examine two more triangle congruence criteria. So before we looked at SAS, which is side angle side, and today we are going to look at angle side angle, which is ASA, and side side side, which is SSS. We're going to add that to the one that we have in the list. So let's talk first about angle side angle. So angle side angle congruence criteria for triangles states that if we are given two triangles, such as triangle ABC and triangle A prime, B prime, C prime, if the measure of angle CAB is equal to the measure of angle C prime, A prime, B prime, and then if the length of side AB is equal to the length of side A prime, B prime, and another angle pair, the measure of angle CBA is equal to the measure of angle C prime, B prime, A prime, then the triangles are congruent. And so what we're looking at here is, instead of having two sides and one angle, we're reversing that relationship. Now we're going to have two angles and one side. And it has to be a specific location for that particular side. The side in question needs to be the side that the two angles share, the one that they have in common. Okay? So we are going to walk through the same transformation proof that we did for why side angle side worked. Here we have two triangles, ABC and A prime, B prime, C prime, that meet the criteria for angle side angle. We are going to first translate triangle A prime, B prime, C prime using the vector B prime, B, so that the point B prime will map up with the point B. So now the point B prime has been mapped to B, so we're going to rotate the figure around the angle ABA double prime until those two congruent sides can line up together. This is the most general case. They were two distinct triangles to begin with, meaning they didn't share anything that was in common. And we can start from here. This is where it's going to look different. This is the only part that's going to look different than when we did the other one. So in order to map triangle ABC triple prime to triangle ABC, we want to obviously apply a reflection across the line AB. So a reflection will map A to A and B to B. Those don't move since they're on the line of reflection. However, we can say that the reflection of C triple prime is equal to what? Is it going to be equal to the actual location of C? So we know that the reflection of C triple prime is going to be over, up at the top, somewhere where C is located. So we know that for sure. So reflecting C triple prime over the line of reflection, we know it at least lands in the same half plane as the original point C. But how can we be sure that they map to each other? Well, it has to do with those angles. So first we know that since the two B angles are congruent to each other, then that means that the ray down at the bottom, the BC triple prime ray, has to map up to the BC ray. They're going to map together. Okay? We also know that since the two A angles are the same, that was already given to us at the beginning, remember? Then the ray AC triple prime has to map up to the ray AC. So then the question is, where those rays, are they going to end at the point C? That's the whole idea. And so you can see that where those two rays intersect is where C must land, since they have the same angles there. So since we have that intersection, and point C has to be on both of those rays somewhere, okay? Point C has to be on the ray AC and has to be on the ray BC. So the intersection of the two rays is where point C has to occur. And we can see in the diagram that that is where the reflection of C triple prime is going to land, since they both occur at both of those intersections. So therefore we can say that C triple prime will in fact reflect to point C. So we just used a series of rigid motions to show that two triangles that meet the angle-side-angle criteria will map to each other and therefore will be congruent. So let's move on to the next one. Side, side, side. So the side, side, side congruence criteria for triangles states that if you are given two triangles, triangle ABC, triangle A prime, B prime, C prime, then if we know that AB is equal to A prime, B prime, a side, AC is equal to A prime, C prime, another side, and BC is equal to B prime, C prime, a third side, then the two triangles are congruent. So let's walk through this proof. We begin by drawing our vector from C prime C and using that as our translation to map those points together, and then rotating about point C to close the gap. And so here we are at that same point where it looks like we would do a reflection, right? Not this time. Without any information about any of the angles right now, we can't actually perform a reflection. The angles were what helped us make sure that the rays were going to line up in the last problem. So what can we do? Okay. First, let's add a construction. Let's draw an auxiliary line from B to B prime and label the angles created by the auxiliary line as R, S, T, and U. Since AB is equal to AB prime and CB is equal to CB prime, we know that these two triangles we're looking at now are isosceles. So that's triangle ABB prime and triangle CBB prime are both isosceles. So what else is that going to tell us? That now means that R is equal to S because they are the base angles of an isosceles triangle. Also, T is equal to U because they are the base angles of an isosceles triangle. Okay, so we know R is equal to S and T is equal to U. How are we going to use that? So let's keep thinking. We also know that R plus T makes that full angle ABC at the top. R and T together makes ABC. We also know that S and U together, using the angle addition, S plus U makes that full angle AB prime C. Well, since both of the pieces are equal, right? We've got the T and the U are equal, the R and the S are equal. That means that the actual two angles themselves are equal. ABC is equal to AB prime C. Okay. Then we can say that the two triangles are congruent by side angle side. Look at that. Did you realize that? There are two sides and we just showed the included angle, which is B and B prime. So we used rigid motions and side angle side to show why side 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 works. Woo! Now we have 3 triangle congruence criteria in our toolbox. Side angle side, angle side angle, and side side side. We will use these 3 criteria to determine whether or not pairs of triangles are congruent.